We are starting with the very fresh chapter today. That is your coordination compounds. Is this chapter done in the school? Kevin, Jason, in the chat box, tell me. Is the chapter done in the school? No, not started. But you know, this is an interesting chapter, little bit different. Like you have not yet studied regarding coordination chemistry till now. Okay, this is something new. You have not studied about it in the school. You have not studied about it in the 11th standard. This is something new that is introduced in the 12th standard to you. So it is interesting, more interesting than your D block and all those chapters. Okay, your coordination is the extension of D block elements. Okay, coordination is an extension of D block element. That's why this year also your chapter, your syllabus is related, most of it. Your NCERT, I'm saying, the central board, they have deleted most of the syllabus, but they have kept D and F and coordination together. They have kept two chapters from inorganic. So why they have kept coordination? Because it is the continuation of D and F. Okay, so D and F we have completed. We have done the chapter assessment of the D and F. Okay, so today we are starting with the coordination compound. So sure, let us begin. Good evening, Anne. You are late. Good evening, Prashanthi. I am waiting for everyone because this is a new chapter. This is something new that if anyone joins in between, he or she will not understand. He or she will not understand. That's why I am waiting. Okay, anyways, chalo, let us start. Let us start. Okay. Now, your coordination compound. So in the coordination compound chapter, again, the coordination compound chapter, you will study about coordination compounds. Now, what are these coordination? So you have two types of compound. One is called as double salt. One is called as coordination compound. So coordination compound means they are your complex compound. So your double salt is also a complex compound and coordination compound is also a complex compound. So what is the difference between double salt and a coordination compound? Let me give you the example. Let us say, how many of you have heard about Mohr salt? Good evening, Sasidaran. Good evening, Anmoldev. Please join on time. Don't do late. Good evening, Sarjana. How many of you have heard about Mohr salt? Yes, Jason. And Prashanti has heard about it. Yes, Mohr salt. You must have heard somewhere. Ferrous ammonium sulfate. Very good. Mohr's salt. Mohr salt. So Mohr salt is something like this. Let me write down the formula. Okay. Let us say we have NH4 twice. Okay. NH4 twice. FeSO4 6H2O. Okay. 6H2O. Now, and let me give you an example of coordination compound. Let us say I have NiCO4 Cl2. Okay, NiCO4 Cl2. So this is your double salt. This is your double salt. Okay, and this is your coordination compound. Okay, by looking at it, tell me what visual difference you can see. What visual difference you can see, Jason, in the chat box, Kevin and Sarjana, Anmoldeep. What visual difference you can see between your coordination compound, okay, and your double salt? What visual difference you can see? Yes? What visual difference we can see, Sarjana? Please join on time from next time. It is already 7:10. It is a new chapter, so I waited because I did not wanted you to miss anything. Okay, so do not keep me waiting. Please join on time, everyone who join after 7:05. Okay, what is the visual difference? See, no, what is the visual difference? What is the visual difference between double salt and the coordination compound? Yes, Jason, can you see something? Like I have written the formula of double salt and I have written the formula of coordination compound. What is the visual difference? What you can see at the formula? Okay, second one is complex, but why? Sarjana? The main difference. Can you see the brackets? Can you see the brackets? Yeah. I'm asking about visual difference. It can be anything, no? Why you are thinking chemistry wise? Okay, I'm asking what difference you can see after you read the compound. One thing you can observe is in the double salt, have I made any square bracket? Okay, have I made any square bracket? And no, I have not. But in the coordination complex, in the coordination compound, I have made a square bracket. I have made a square bracket. So that is the first visual difference we see. Now, what is the importance of it? Let's see. So let us say I have put this double salt. I have put this double salt in the aqueous medium in the water. Okay. I have put the double salt and the coordination compound, both of them in the aqueous medium. Okay, both of them in the aqueous medium. So your double salt, write it down, double salt loses its identity. I'll explain you what it is. First, write it down. Double salt in aqueous medium loses its identity. Double salt in aqueous medium loses its identity, while coordination compound retains its identity in aqueous medium. I'll explain it. First, write it down. Double salt loses its identity in aqueous medium. Coordination compound retains its identity in aqueous medium. Okay, retains its identity in aqueous medium. Come on, write it down. Loses its identity, retains its identity. Okay, and write down the example also. Write down the example also. Write down the example also. Loses its identity, retains its identity. Okay. Now look over here. What is the meaning of this loses its identity? Like for example, Anne, Jason, Sarjana, if I put NaCl, a whole NaCl cube into water, what do I get? I get the ions. Okay, that is Na plus and Cl minus. That means NaCl has lost its identity. Okay, so loses its identity means what? When I put Mohr salt into aqueous medium, it does not remain Mohr salt. All the atoms, all the elements, they turn into iron. All of them. Like you have ammonia over here, it will become NH4 plus. Okay, it will become NH4 plus. Then you have Fe, that will become Fe2 plus. You have SO4, it will become SO4 2 minus. So what has happened? Everything has turned into ionic form. Everything has turned into ionic form. I do not have anything as Mohr salt as whole in the aqueous medium. Are you getting it, everyone? I do not have complete double salt. I do not have complete Mohr salt in my aqueous medium. As I put Mohr salt in the aqueous medium, I tried to stir it. What has happened? Everything has turned into ions. I do not have Mohr salt as a whole together in the aqueous medium. And that is the meaning that it loses its identity. It does not remain Mohr salt in the aqueous medium. What has become? It has become into ions. Now your coordination compound, when I dissolve it in water, when I stir it in the water, when I dissociate in the water, it does not dissociate completely. It dissociates your square bracket, the complex remain as it is. That means what? The identity is retained. The complex, like for example, this is your AB2 type of solution, AB2 type of complex. Tell me, AB2 type of complex, tell me what will be the charge on A? Am I lagging, everyone? Are you able to hear me properly? Am I lagging? No, no? What will be the charge on A? Come on, tell me. Okay. What will be the charge on A? Will it be positive? Will it be negative? Yes. If I have AB2 type of complex, Sajna, Anthony, Kevin, Sasidharan, Gopinath, getting it in. Yes, what will be the charge on A? Yes, what will be the charge on A? Come on, tell me. If I have AB2 type of complex, how does it dissociate? AB2 complex, how will your AB2 complex or AB2 compound dissociate? Sajna. Yes, how does AB2 dissociate? Yes, Jason, will that be positive? Will that be negative? Yes, Kevin, Sasidharan, come on, tell me. Prashanti, Anthony. How will AB2 dissociate? What will be the charge on A? What will be the charge on B? Yes, you must have done this in the school, 10th standard or 9th standard if I'm not wrong. Yeah, the cross method. The cross method. Look over here.
Sir,
Yes,
charge
Sasidaran.
on A will be +2, sir.
And what will be the charge on B?
Like single charge of B will be -1, so 2 into B is -2.
Ah, okay. So look over here. Those who do not know, remember this cross method. Remember this cross method. Okay. Like for example, what I have over here, suppose this is A, this is B. Okay. So on A, I have 1 over here. On B, I have 2. Okay. So 2 goes on A. Okay. And first we always, first we write down the positive ion. Okay. So A, 2 plus this will go on the B, which is negative. So B minus. Okay. So it will be 2B minus. Is it clear, everyone? Is it clear? Similarly, suppose I have CaCl2. Same example. What will be the charge on Ca? What will be the charge on Cl? Quick. Let me check if you have got it. What I just want the charge. I just want the charge. Correct. And what will be the charge on Ca? What will be the charge on Cl? Yes, Arjuna. Kevin, Anthony, Prashanti, Gopinath, come on, tell me. Correct, Kevin. I just want the charge. Okay, very good, Sasidaran. Yes, correct, Jason. So I have Ca2 plus 2 Cl minus. Okay. Similarly, tell me now, Sarjana, Kevin, H2SO4. What will be the charge on H? What will be the charge on H? Sasidaran. What will be the charge on H? Sarjana, what will be the charge on H? Okay. Jason. Prashanti. I knew it. At least one of you will do the mistake. That's why I gave you this question. I knew it that one of you, Kevin, has done the mistake this time. Kevin, we have something called as polyatomic ion. Can your H be ever 4 plus? Does your H even contain 4 electrons that you'll remove 4 electrons from H? Huh? No, it is not possible. Your SO4 is whole together an ion. This is your polyatomic ion, isn't it? This is called as, everyone, this is called as what? This is your polyatomic ion. Okay, so again, this is your A to B type of complex. Kevin, this is your A to B type of complex. So what will happen? B1 is there, that will go on top of A, that is our H over here. So H plus, this 2 will go on the top of SO4 plus, SO4, 2 minus. And how many H plus we have? We have 2 H plus. Is it clear, Kevin? Is it clear, everyone? Yeah. So please do not do this silly mistake. Okay. Many a times in the competitive exam, when we are solving, we do this silly mistake. So do not do that silly mistake. Okay. Is the difference between your double salt and the coordination compound clear, everyone? Is the difference, main difference, is it clear? Okay. Chalo. Now let us go ahead. Let us understand about some common terms. Okay. Some important definitions. Okay. Important terms that we are going to use throughout the chapter. Some important terms, okay, that we are going to use throughout the chapter. Some important terms that we are going to use throughout the chapter. Okay. So we are going to use some terms like coordination entity. Okay. There is some term like coordination entity. Now entity means what? The whole species. Okay. So when I say coordination entity, that means coordination compound. Simple. Okay, coordination entity, if I say this is a coordination entity, so whole compound is a coordination entity. Okay, whatever compound I will write is a coordination entity. Okay, then we have something called as central atom. We have something called as central atom. We have something called as central atom. For example, suppose I have COCl, okay, let us say NH3 I2. Okay, NH3 I2. Okay, this is my whole is a coordination entity. Okay, in that this square bracket, I call it as coordination sphere. That we call as coordination sphere. That is a coordination sphere. Okay, now when I say central atom, now central atom means what? Central atom means the main atom to which everything is attached. The main atom to which everything is attached. Can you identify from this? It is fine even if you are wrong, because I have not yet taught you. Can you identify the central atom over here? Can you identify? Just look at it. Is completely fine if you go wrong. I have not yet taught you, so it is fine if you go wrong. But try. Come on, can you identify? What is the central atom? Okay. 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 Yes, Anthony, try. Kevin, what will be the central atom? See, central atom means the main atom to which everything is attached. The main atom to which everything is attached. Now in the coordination compound, very good, Sarchna. In the coordination compound, the central atom is always a metal. The central atom is always a metal. Okay. For example, over here, your cobalt is the central atom. Please write it down. Over here, your central atom is cobalt. Why? Because to the cobalt, I will attach all the NH3. I will attach the Cl. Are you getting it, everyone? Yeah. So this is like a structure. Okay, NH3, NH3. Okay, I. Are you getting it, everyone? So my central atom is what? My central atom is cobalt. So this central atom will always and always be metal in our coordination compound. Write it down if you want. Central atom will always be over here, metal. That is why we are studying the coordination compound after D block, because those are your metals. Yeah. So central atom will always be a metal. Okay. And this I2, okay, this I2 we call it as counter ion. Okay, this I2 we call it as counter ion. Now what do we meaning by counter ion? Okay, those are just there to satisfy the charge. Those are just there to satisfy the charge. What is the meaning? If I dissociate this, my square bracket will get 2 plus. So to satisfy that, I have 2i minus. Okay, to satisfy that, I have 2i minus. So counter ion will always and always be outside the square bracket. Write it down. Counter ion always outside square bracket. Always. I'll explain you why there is a bracket, why we have counter ion, but let's go step by step. Write it down. Counter ion always outside square bracket. Always outside square bracket. Okay, so CO is your central atom, which will always be a metal. The bracket, the square bracket, we call it as a coordination sphere. That is our main complex. And whatever is outside the coordination sphere, or whatever is outside the square bracket, we call it as a counter ion. We call it as a counter ion. Come on, give me yes or no. Is everyone clear? Is everyone clear? Come on, give me yes or no in the chat box. I hope no one has doubt. Is everyone clear? Only Anna said yes. Arjuna, Kevin, Sasidaran, Jason.
Sir? Sir?
Yes, Anthony.
Sir, can you explain again, sir?
What you want to know again? Tell me.
Sir, what you explain now, sir? Like counter ion you told us, sir. I think can you explain?
And Anthony, please do not join class late. This is a new chapter. Okay, so obviously if you join late, you will not understand. Okay, so
Okay,
kindly join on time. I'll explain you once again. That's not the issue, but it goes to everyone. Everyone, please join class on time. Do not keep me waiting for like 10 minutes, 15 minutes. Not good. Very disrespectful. Okay, now look over here, Anthony. Over here, this is your coordination compound. Okay, whatever we write with the square bracket and the ions, this is your coordination compound. Okay, this is your coordination compound. Okay, now Anthony, your coordination compound contain a coordination sphere. Okay, that square bracket is your, we call it as a coordination sphere. Now inside that square bracket, Anthony, we have something called a central atom. Now in the square bracket, you will see what is your metal. That metal will be your central atom. Always and always, the metal will be your central atom. And generally, we write central atom first. Although we name it as central atom, but we write it first. Okay, we name it as central atom, but generally we write it as first. Okay, so a central atom will always be a metal to which everything is attached. To which everything is attached. Okay, Anthony, that is a central atom. Now, whatever is written outside the square bracket, Anthony, whatever is written outside the square bracket is called as counter ion. Okay, Anthony, whatever is written outside the square bracket is called as counter ion. Okay, so for example, over here, I have a whole square bracket that I will write it as A. I have counter ion that is I will write it as B. Okay, so I have AB2 type of complex. So Anthony, if I dissociate that, how it will get dissociate? A will get 2 plus 2B minus. Okay, so this basically it has +2 charge. Clear, Anthony? Is it clear? Okay. Chalo, let us go
Sir.
ahead now. Let us go to the next part.
Sir,
Yes, Anthony?
sir, what is that +2 charge, sir?
+2 charge, Anthony, you get when you dissolve something. Like for example, Anthony, suppose you have NaCl, correct? So
Yes,
if
sir.
I dissolve it in the water, how will it dissociate? Tell me. If you dissolve it in the water, it will dissociate into ions, isn't it?
Yes, sir.
So how it will dissociate into ions? How will it dissociate into ion? If I separate Na and Cl, what charge will come on them?
Positive charge, sir.
And what about Cl?
Negative charge.
So why there is a positive negative? Because over here 1 1 is there. Okay, so if I dissociate, then I get Na plus Cl minus. Similarly, Anthony, if I dissociate CaCl2, how will it dissociate? Tell me.
Ca positive, sir.
But positive, 1 positive, 2 positive, 3 positive. C, it is CaCl2. So always remember this rule, Anthony, that your cross rule. Okay, your Ca is 1, Cl is 2. Okay, so whatever it is, it will get exchanged. It will get exchanged. Okay, so 2 will go on top of Ca. So it is Ca2 plus, and always, Anthony, we write down the positive atom first. Okay, so on the Ca we get the 2 plus. Okay, on the Cl we get the 1 minus. And how many Cl we have, Anthony? We have 2 Cl. We have 2 Cl. Getting it? And similarly, is it clear, Anthony? First tell me yes or no. Is it clear?
Yes, sir. Clear, sir.
Is it clear, Anthony?
Yes, sir. Clear, sir.
Okay, similarly, Anthony, look over here. Do not mute yourself. Look over here. Suppose I have a complex like this, what I have drawn on the previous page. COCl NH3 I2. Correct? I have drawn this. So your whole bracket, Anthony, is considered as A. Your I is considered as B. So AB2. So AB2, just like your CaCl2, how will it dissociate? A will get 2 plus charge, correct? B will
Yes,
get
sir.
-1 charge. So that is why your A has 2 plus charge. Getting it now?
Yes, sir. Yes, sir. Got it, sir.
Okay, sure. Let us go
Thank
ahead.
you, sir.
Okay. Now let us go to the next part, ligand. Okay, this is something completely new that you must be hearing. You have not heard this word in the 11th standard or school level, never ever. Okay, ligand. Now what is this ligand? Okay, so ligand simply now, for example, the last example, let us take again the last example. We had COCl NH3 5. Okay, and I have I2. Correct? So whatever except central atom and counter ion, whatever is written in the square bracket except central atom are your ligands. Okay, whatever that is written in the square bracket except your central atom is ligand. Okay, so ligand are directly attached to the central atom. Ligand are directly attached. Ligands are directly attached to the central atom. Okay, they are directly attached to the central atom, and we call them as donor atoms. Why? Because they give the electrons to form a bond. Okay, write it down, directly attached to the central atom. So donor atoms that atom are called as ligand. Donor atoms that are directly attached to the central atom are called as ligand. Okay, directly attached to the central atom, or you can write it as central metal atom. Okay, these are your ligands. Is it clear, everyone? So we have a metal, we have a ligand. Ligand donates its electron. Okay, ligand donates its lone pair of electron to metal to form a bond. Okay, ligand donates its lone pair of electron to the central metal and it form a bond, and that is a ligand. Clear, everyone? Come on, give me yes or no in the chat box, and then go ahead. Is it clear? Okay. Now in this compound, tell me, what are my ligands? What are my ligands? Yes, Jason, Kevin, and Sarjana. What are my ligands? I have drawn over there. Correct, Jason. Very good. Yes, Sarjana and Kevin, Anthony. What are my ligands? Very good, Sarjana. Very good, Anne. So I have two types of ligand and total 6 ligand. Are you getting it, Sarjana? I have two types of ligand. One is your Cl, one is your NH3, and total there are 6 ligand. 5 NH3, 1 Cl. Is it clear, everyone? Come on, give me yes or no. So my ligands over here, Anthony, are Cl and NH3. Cl and NH3 are my ligands because they are directly attached to the central metal inside the square bracket. Okay, and again, this is my counter ion. This is my counter ion. Okay, Shalo, let us go ahead. Okay, let us go ahead. Now, with respect to ligands, now there are various type of ligands. Okay, now we are attaching ligand to the central metal atom. Okay, so there are various type of ligands. So give the heading, everyone. Types of ligands. Give the heading. Types of ligands. Give the heading. Types of ligands. Give the heading. Types of ligands. Types of, give the heading. Okay, so types of ligand. First type of ligand we have is a mono, or we call it as a unidentate. Okay, monodentate ligand. Give the first type of ligand, everyone write it down. Monodentate ligand. Monodentate ligand, or it is also called as unidentate, or it is also called as unidentate. Okay, monodentate or unidentate ligand. Okay, monodentate or unidentate. Simple, simple, simple. Mono means what? Simple. It is one. Okay, so it contains one donor atom. Okay, which gives you one electron pair. So simply it contains one donor atom, and one site, and occupies only one site. Okay, so it occupies only one site. Okay, so it contains one donor atom and it occupies one site. Simple, simple. Your F minus, even your ammonia, your Cl minus, okay, your Br minus, H2O, these are all your monodentate ligand. Why? Because they form a single bond basically. Are you getting it, everyone? Yeah, they are just occupying only one site. They have only one donor atom. They form only one bond. Okay, even ammonia, even your Cn minus, NO2, OH minus, and CO. Okay, etc. etc. I want to write down the example. These are your monodentate ligand. I hope you are getting it. Yeah, they form whatever you seeing on the screen, whatever the examples written on the screen. They have only one donor atom. They form only a single bond. Simple. They form only a single bond. Such ligands we call it as a monodentate ligand. Such ligands we call it as a monodentate ligand. Monodentate ligand. Come on, write down the examples and done in the chat box. Write down the examples and done in the chat box. Kevin is done, Anne is done. Okay, Sarjana is also done. Anthony, write it down. Jason, write it down and done in the chat box. Okay, fine. So this is your unidentate or monodentate ligand. Generally, we use the word monodentate. Generally, we use the term monodentate. Remember. Okay, generally we use the term monodentate. Sorry. Monodentate or unidentate. Okay. Now the next type, as the name suggests, after monodentate we have something called as bidentate. We have something called as
Sir, can you show me 1 second, sir?
Yes, Anthony.
So, last slide, can you show?
Okay. Write it down.
Sir, done, sir. Thank you, sir.
Done, Anthony.
Yes, sir.
So next is everyone is what is your bidentate ligand? As the name suggests, your monodentate ligand was what? Monodentate ligand was having one donor atom. So this will have what? This will have two donor atoms and occupies two sides. Okay, two donor atom, and both of the atom will donate. For example, there is something called as ethylene diamine. Okay, ethylene diamine. There is something called as ethylene diamine. Okay, ethylene diamine, we write it like EN. Okay, we do not write down the whole ethylene diamine in the bracket. For example, if I have CuEn twice, let us say Br2, CuEn twice Br2. Okay, so En means what? Ethylene diamine. So as the name suggests, diamine, that means what? It will have two amine group. It will have a two amine group in a single ligand. For example, look over here. Ethylene diamine, it looks like this. Suppose I have CH2, that is your ethylene. Diamine means I have NH2. So let us say our central atom is what? Central atom is copper. So copper, so this nitrogen has donated. Are you getting it, everyone? So I have a single ligand, but it is forming two bonds. Why? Because it has two donor atoms and both the donor atoms are donating electrons to form a bond. Both the donor atoms are donating electrons to form a bond. So over here, both the NH2 are donating to form a bond. Similarly, suppose I have NH2 over here, okay, again CH2, correct? Again, one more ethylene diamine, that is this structure I am drawing. CuEn twice. Over here also this will form a bond. Over here also this will form a bond. Are you getting it, everyone? Yes or no? Bidentate ligand means what? A single ligand. This is a single ligand, ethylene diamine, is having two donor atoms in the form of two ammonia molecule. And two ammonia are forming a bond with the copper. Clear? Jason, come on, write down the structure. I'll explain you one more important term. Write down the structure, everyone, and done in the chat box. Write down the structure and done in the box. Done in the chat box. Okay. Now there is something called as coordination number. Okay. There is something called as coordination number. Okay. This word you must have used up. You heard about it. Yeah. Coordination number. Now what is this coordination number? Simple. Simple. If I ask you coordination number of any metal in the complex, you have to see how many. Simple as that. What you have to see, coordination number, you have to see how many bonds it has formed. How many bond it has formed. Simple. You have to check, okay, it is forming 4 bonds. So coordination number 4. Okay. So you have to check your central atom, okay, is forming how many bond. It is forming how many bonds. For example, look over here. Suppose I have the last example we took. Let us say I have Fe, or we had cobalt. We had taken cobalt. So let us say I have cobalt. Okay. Cl NH3 5 I2. This was our example. Okay. So if I ask you what is the coordination number of central atom cobalt? Okay. So you have to see how many directly attached ligand. Okay. Not the counter ion. How many directly attached ligand are present and how many bonds they are forming. So the total number of bonds will be your coordination number. Are you getting it, everyone? Yeah? Sajna, is it clear? So over here, tell me what will be the coordination number of cobalt? Yeah? All of them are unidentate or monodentate ligand. Yes, Jason, what will be the coordination number? Sasidharan, Kevin, what will be the coordination number? Yeah? No, and you do not have to count the counter ions. I've told you it is just the ligands you have to count. Yeah, it is just the ligand you have to count. You do not have to count the counter ion. You do not have to count the counter ion. Okay, it's just the ligand you have to count. Correct? So over here, correct, we have 6 coordination number. Why? Because, and remember, it is not equal to total number of ligand. It is equal to total number of bonds your ligand are forming. Okay, it is equal to total number of bonds your ligand are forming. Over here, Cl is forming 1 bond. Over here, 1 NH3 is forming 1 bond. So 5 NH3, 1 Cl. The coordination number is what? The coordination number is 6. Is it clear, everyone? Come on, give me yes or no in the chat box. Is the coordination number concept clear? Sajna, is it clear? Okay. Now, Sasidharan, Jason, come on, tell me. Kevin, tell me what will be the coordination number of copper over here? What will be the coordination number? What will be the coordination number? Yes? What will be the coordination number? Yes, and Sajna, come on, tell me. Sindhuja, what will be the coordination number of copper in Cu, En2, Br2? Yes, Sajna. What will be the coordination number? Sindhuja, come on, tell me. Correct, Jason. Correct, Sajna. Gopinath, Prashanti, Ragul, Anthony. What will be the coordination number over here? Look at the structure now. I have just drawn it beside the molecule. Sasidharan, look at the structure I have drawn just beside the molecule. No? What is coordination number? Coordination number means simply how many bonds it is forming with ligand. Bonds with ligand. It is not equal to ligand. Please understand this, Sasidharan. It is how many bonds it is forming with ligand. It is not equal to ligand. For example, over here I have 2 ligands, but that does not mean that the coordination number will 2. Sasidharan, are you getting it? Over here, the coordination number is 4. Why? Because we have bidentate ligand. One ligand is forming 2 bonds. So 2 ligands will form how many bonds? It will form 4 bonds. And this is the proof. This is the structure. 1, 2, 3, 4. Are you getting it, everyone? So coordination number, please remember, do not do this mistake. Coordination number is not equal to number of ligands. It is equal to number of bonds that ligands are forming. Is it clear, Sarjana? Is it clear, Sasidharan? Now, okay, so it is not 2 over here. The answer should be 4. The answer should be 4. Okay. Now, let us go ahead. Yeah. Now, I am giving you examples. Sasidharan, please open the flap of your webcam. Okay. So, I am giving you examples now. After the class, kindly write down those examples in the book. Okay, I am giving you the example, all of the possible examples we know of bidentate, tridentate, tetradentate. Okay, so these are your bidentate ligand. Let me give you the examples after the class. If you want, take a screenshot now, and after the class, write it down with the structure and with the short form. With the short form. See, look over here. This is your EN. Just now we did ethylene diamine, EN. Correct? Then you have OX, which is your oxalate. It also contains 2 oxygen donor atoms. Then we have 110 phenanthroline. 110 phenanthroline. It also contains 2 nitrogen. So these are all your bidentate ligand. Come on, take a screenshot of this, and after the class, you have to write down in the book. After the class, you have to write down in the book. These are all your bidentate ligand. These all your bidentate ligand. These all are your bidentate ligand. Okay. Similarly, there are tridentate. Now you only tell me. I will not waste my energy. Come on, you tell me what is tridentate ligand. Yes. What is a tridentate ligand? Yes. And Sarjana, Jason, Kevin, in the chat box in small, in short. Yes, Anthony.
Sir,
Yes, Sasidharan.
sir, in every ligands, like in every compounds here, you can see like 2 arrows are coming from compounds. Sir. So if 3 arrows comes means to this, like the arrows meet at a point that the point is for central atom, sir.
Yes,
So
that is
when
possible.
3 arrows come to the central atom, it is called
But you cannot write in the exam. Will you write definition like this, Sasidharan? That 3 arrows are coming from the compound, so I call it as tridentate. No, na? We cannot write it like that. Those arrows are for your reference. Those arrows, because those are your coordination bond. Okay. Like in the exam, they will not give you arrow. They will give you directly like this. C, O minus, O minus. Okay. This is your structure of bidentate ligand. I draw arrow, I do not draw arrow, does not matter. Those arrow are just showing bonds. Are you getting it?
yes.
So in the exam, we cannot say it is equal to arrows. Okay, we can say it is equal to the donor atom. Now over here, Sasidharan, although we have 4 oxygen, okay, but out of that, only 2 are donating. Are you getting it, everyone? Only 2 are donating. That's why it is bidentate. That's why it is bidentate. So obviously, Sasidharan, if I say tridentate, tridentate means what, everyone? Tridentate means I have 3 donor atoms. 3 donor atoms. Similarly, if I have tetradentate, tetradentate will be 4 donor atoms. For example, look over here, everyone. For example, again, take a screenshot of this and draw it after the class. Okay. Generally, tetradentate and all do not come much in the NEET. It comes in the JEE, but you should know this. It is there in the syllabus. Okay. For example, tridentate. Look over here. Diethylene triamine. Triamine. 3 nitrogen. 3 nitrogen. 3 donor atoms. So over here, 1, 2, 3. Similarly, we had 110 phenanthroline. Over here, 2 prime, 2 double prime. Terpyridine. Because we have 3 donor atoms. Over here also nitroacetate. Yes, 3 donor atoms. Similarly, triene, triethylene tetraamine. Yeah. So over here, sorry, these are your 4 donor atoms. So sorry, tetradentate. So 1, 2, 3, and even your nitrogen contains a donor atom. Yeah, a nitrogen contains a donor atom. Okay, so 1, 2, 3, and the fourth is the nitrogen. That is a tetradentate. That means 4 donor atoms. Correct? Then you have triethylene tetraamine. Tetra means 4. So 4 amine, 4 nitrogen, it will donate. Is it clear, everyone? Bi, di, tri, tetra. Sarjana, is it clear? Okay, then similarly we have the last one, the hexadentate. Okay, we have something called as hexadentate. Obviously hexadentate, that means what? A single donor, a single ligand will have 6 donor atoms. Your single ligand will have a 6 donor atom. Okay, for example, now I am giving you one structure. Let us check, can you identify it? Okay, I am giving you structure. I am saying that you know the name, you have heard about the name of the structure. Just look at the structure. Can you identify the name? Can you identify the name? I do not expect you to, but can you? Can you identify the name? Yeah. I'll simplify the structure. I'll simplify the structure. Okay, our structure is like this. CH2, CH2, N, N. Okay. CH2, 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 COO minus, COO minus, COO minus, COO minus. Can anyone identify this? Can identify the name? Okay, look over here. I'll tell you. 2 carbons means what? 2 carbon means it is ethylene. Correct? 2 nitrogens means what? Sasidharan? Diamine. Yeah? Ethylene diamine. 1, 2, 3, 4. 4 acetate structures. EDTA. Ethylene diamine tetraacetate. I hope you have heard about it. Sarjana? No? Not heard? Achha. Chalo, anyways, write it down. Ethylene diamine tetraacetate. I thought that you must have heard about it. Chalo, anyways. You will have this in practicals, definitely in the engineering. Ethylene diamine tetraacetate. Tetraacetate. Just a minute, everyone. Yes, EDTA, ethylene diamine tetraacetate. Ethylene diamine tetraacetate. Is it done, everyone? Okay, now after the class, you have to write it down. Okay, after the class, you have to write it down. Okay, and there's one more type I want to tell. Okay, then we'll go to IUPAC. After that, I'll give you a break after this. Don't worry, I can see your faces. Okay, this is your something called as chelating ligands. Okay, chelating, some teachers pronounce it as chelating. Okay, you pronounce what you want. Okay, but write down correctly. It is called as, I call it as chelating. Okay, chelating ligands. Okay, now what are these chelating ligands? Okay, chelating ligands means, for example, ethylene diamine. For example, ethylene diamine. Now, what is this chelating ligand? Chelating ligand means it is a cyclic structure. Okay, that ligands which form a cyclic structure. For example, again, let us take the example of your CuEn twice. CuEn twice. So I have Cu. Okay, En means we have seen ethylene diamine. Okay, so ethylene diamine, isn't it forming a cycle like a structure? Yeah, ethylene diamine, it forms 4 bond. Doesn't it form a closed cycle? Are you getting it? Cycle means what? This is also a cycle. This is also a cycle. A closed structure is called a cycle. Are you getting it, everyone? Yeah. So even your CuEn twice, CuEn twice, we have seen the structure. Where did our structure go? Yes, CuEn twice. Over here, we have seen the structure of CuEn twice. Okay. Isn't it forming a cycle? 5 membered and 5 membered together. Yeah. Getting the point. Okay. It is like this. Yeah. Isn't it like this? 2 cyclic structure. Okay. So the ligands that form a cyclic structure. Write it down. The ligands that form the ligands that form cyclic structure. Ligands that form cyclic structure. Ligands that form cyclic structure are called as chelating ligands. Are called as chelating ligands. So basically, those chelating ligands increases the stability. Okay, it increases the stability of structure. It increases the stability of structure because since it is a closed cycle, it is holding the atoms more properly. Okay, increases the stability of structure or complex. Okay, and one more thing, if I have larger molecules in the cycle and if I have a smaller molecule, obviously your smaller molecule will be more stable. Your smaller molecule will be more stable than the larger molecule. Yes, your smaller molecule chain will be more stable than larger molecule chain in the ligand. Are you getting it, everyone? Are you getting it? Come on, give me yes or no. Okay, so if I have 2 ring and if one ring is having smaller atom and one ring is having larger atom, obviously the one with the smaller atom will be more stable because it is giving you less strain. Yeah, it is giving you less strain. Okay, come on, write it down and done in the chat box. Write it down and done in the chat box. Done, done. Okay, chalo, it is what is the time? It's 7:59. Yeah, 7:59, 7:58. Okay, let's take a break. Okay, everyone, drink water, but please come on time. Okay, I want everyone back by 8:09 so that I can start at 8:10. Okay, please do not do late. Okay, we have to finish it. Okay, come on, take a break. After this, we'll do the IUPAC nomenclature and oxidation stage. Yes, everyone, come on, back in the chat box. Everyone back. Come on, everyone, back in the chat box. Turn on your cameras. Come on, everyone, back in the chat box. Anthony, Sasidaran, Jason, turn on your cameras. Okay, chalo. All freshen up. Yeah, fine. Okay, chalo. Let us go ahead now. Okay, now one last thing before heading to IUPAC nomenclature. Oxidation state. Yes, we carry out so many oxidation state. What is actually oxidation state? If I ask you, what is oxidation state? Like, what is the meaning of oxidation state? I know you will say you have compound, you have the oxidation state, but what is the meaning of oxidation state? Yes, Arjuna? When I say oxidation state, what is the meaning of that? Yes? Oxidation state. What is the meaning of oxidation state? Yes? Jason? What is the meaning of oxidation state? Okay, very good, Ad. Yes, Jason?
It's a charge of an atom, sir.
Correct. When I say oxidation state basically means what? What is the charge on that atom or element? Simple as that. Simple as that charge. For example, suppose I have cobalt. Let us take the same example. ClNH3 5I2. What is the oxidation state of cobalt over here? Come on. Can you identify? What will be the Come on, try. It is fine even if you are wrong. I'll help you. Come on. It is fine even if you are wrong. I'll help you. What is the oxidation state of cobalt? Yeah. What is the oxidation state of cobalt? Yes. Oxidation state of cobalt. Yes, everyone. Come on, fine. It is fine even if you're wrong, I am telling you. Yes. Come on, tell me. Try. Fine even if you're wrong. I am giving you permission. Give me wrong answer. It is fine. Yes, what will be the oxidation state of cobalt? Arjuna, Jason, come on, try. Sasidaran, Ragul, Prashanti, try. Gopinath, try. Yes, come on, try. Okay, chalo. I'll give you a hint. Cl is -1. Ammonia is neutral. Ammonia is neutral. Those who are neutral, the charge is 0. Those who are neutral, the charge is 0. Come on, now try. Sarjana. Those who are neutral, the charge is 0. Come on, try. Jason. Okay. Those who are neutral, their charge is 0. Those who are neutral, their charge is 0. What will be the oxidation state of cobalt? Yes, Arjuna? Come on. Nah? Look over here. What is cobalt? First of all, write down the complex correctly. Okay, Jason? Write down the complex correctly. Okay? You do not have to ignore I2. Yes, when there is I2, what is the meaning of that? When there is a I2, meaning there is a charge over here. Yeah, Whenever there is a counter ion, that means there is a charge on your complex. So our actual complex is COCl NH3 2 plus. NH3 2 plus. So simple over here, Jason, Sarjana, cobalt I'll take it as X, chlorine I'll take chloride, I'll take it as -1, ammonia is 0, it is neutral. So plus 0 is equal to 2 plus. So X 2 minus 1, no, -1 will go to that side, will become +1, X is equal to +3. Is it clear, Sasidharan and Sajna, Jason? Is it clear? Is it clear? Okay, should I give you one more? Okay, K4Fe CN6. Okay, what is the charge on Cn, everyone? What is the charge on Cn? Yes, what is the charge on Cn in general? Correct, Jason? Cn is -1. Chalo, I have given you hint. Find out Fe. Find out Fe oxidation state. Find out the oxidation state of Fe. Find out the oxidation state of Fe. Very good, Anne. Yes. Find out the oxidation state of Fe. Come on, Sarjana. What happened? You're not solving any questions today. What will be the oxidation state? I have taught you now. If you have any doubt, you can ask. Jason. Correct, Jason. Correct, Sarjana. Very good. So over here, it is +2. How? Kevin, Sasidharan, how? Look over here. So if I dissociate this, what will be the charge on the complex now? If I dissociate this, the charge on the complex, since it is 4, this becomes 4 minus. Yes, are you getting it? Minus. So Fe, that I'll take it as X, -6 is equal to -4. Goes -6 goes that side, become +6, +6 minus 4 is +2. Is it clear, everyone? How to find out the oxidation state? Is it clear? Okay. Now, in the end of the lecture, I'll be sharing all the possible ligands, all the possible name of those ligands. Okay. After we do IUPAC nomenclature, I'll share all the names. I'll share all the names of the ligand. Or while doing IUPAC, only I'll share all the possible ligands. You write it down after the class. Okay. Now, chalo, let us come to the important, give the important, very, very important heading. Definitely one question in the exam, that is IUPAC nomenclature of your coordination compounds. Definitely in the exam. IUPAC nomenclature. IUPAC nomenclature. Okay. IUPAC nomenclature or IUPAC nomenclature. IUPAC nomenclature. Okay. IUPAC nomenclature. IUPAC nomenclature. Okay. So over here, IUPAC nomenclature, everyone. So there are two sets of rules. Okay, there are two sets of rules for two different compounds. That is, suppose I have compound like this. What we have done in the previous COCl NH3 COCl NH3 I2. Okay, suppose I have a compound K4FeCl. Can you tell me what is the difference? What is the difference over here? What is the difference? Yes, Sarjana and Jason, Kevin. What is the difference between these two compounds? What you can observe? Yes, what can you observe? Yes, what can we observe over here? What is the difference, Sarjana? Yeah, Jason, what is the difference? What can you observe? Come on, tell me. Sasidharan, remove the flap from your webcam, please. Yes, what can we observe? What is the difference? Okay, there is I2 is towards left. Acha, I2 is there. Okay, the main difference, I2 is coming at the last, K4 is coming at starting. Okay, you have correctly identified, but the main difference from that, what happens is, Sarjana, if I dissociate it, my coordination sphere is getting what charge? Over here, in the example A, the coordination sphere get a positive charge, although it is 2 plus, but positive charge. And over there, Sarjana, if I dissociate, my coordination sphere is getting what charge? It is getting the negative charge. Over here, positive sphere, over here, negative sphere. So the rules are different for the positive coordination sphere and the rules are different for the negative coordination sphere. Although there is not much difference, but yes, there is a difference. Is it clear? So let us do the positive complexes, the rules for positive complexes. The rules for positive complexes. Okay, rules for positive complexes. Come on, let us do this. Let us take the example with the nomenclature. Okay, with the help of example, we'll do the nomenclature. Okay, so let us start with the very easy. First, let us take an example of platinum. Okay, let us take example of, we are taking example of positive complexes. Okay, so I have NH3, I have 6 NH3, I have 4 Cl. Okay, now identify, tell me what is the central atom over here. Come on, I want everyone to reply in the chat box. What is the central atom over here? Correct. And Sarjana, Jason, Anthony, Sasidharan. What is the central atom over here? Sasidharan. There's something going on at Sasidharan's place. Sasidharan. Yes. What is the central atom? Perfect. The central atom is platinum. What is the ligand over here? What is the ligand? What is the ligand? What is the ligand? Jason, Sarjana, and correct? Yes, Sarjana, what is the ligand over here? Correct. Ammonia. Correct, Jason. Ammonia. Correct. Ammonia, Anthony, NH3 is our ligand. Correct. NH3 is our ligand. And this is our counter ion. This is our counter ion. Okay. So, first rule, no matter whatever you have, first rule in the positive complex, we write in the order. First, we solve the bracket. Because bracket is what we have first. Okay. So, first we solve the bracket. In that also, we write down the name of ligand first. Okay, remember this. We write down the name of ligand first. Okay. Now, what if we have a multiple ligand? So, those we will write it alphabetically. Okay. So, write down the name of ligands alphabetically. That is the first what we write. Okay. After that, without giving any space, after ligand, we write down the central atom, that is our metal. Okay. So, we write down the ligand. We write down the metal. Okay. Then after metal, we write down the, we write down the oxidation state of that metal. Okay. After that, we write down the oxidation state of the metal. Okay. Then what we write? Then we write down the counter ion. Come on, write this down. Write down this order. Write down this order. Write down this order. Write down the order and done in the chat box. Okay, done. Chalo. Let us write down the name. Okay. So over here, I have ligand. What is my ligand? My ligand is ammonia. Okay, my ligand is ammonia. How many ligands I have? Over here, now I do not write ammonia, we write amine. Okay, we write amine. I'll give you all the names, but for now, remember, we write amine. Okay, we write amine. How many amines I have? So I write 6 amine, so I have hexaamine. Okay, without any space till oxidation state. Okay, hexaamine, hexaamine. Okay, double M amine, hexaamine. Okay, after that my ligands are over. After that, Sarjana, I have the metal again without any space. What is my metal? Metal is platinum. So hexaamine platinum, the name of the metal as it is. Okay, name of the metal as it is, hexaamine platinum. What is the oxidation state of platinum over here? Everyone in the chat box, come on, calculate. Yes, what is the oxidation state? Come on, Sarjana. Yes, correct, Jason, correct. And Sarjana, what is the oxidation state of platinum? Yes, Sarjana, what happened? Come on, calculate. Correct, it is 4. Why? Because Anthony over here, I'll take it as X. Correct. Your ammonia is 0. And Anthony, what is the charge on the square bracket? It is 4 over here, so it will be plus 4. So X is plus 4. Are you getting it, everyone? Yeah. So oxidation state you have to write in the Roman number. Okay. 4. Plus minus doesn't matter. You have to write it in the Roman number. Okay. If it was negative, we wouldn't be writing like this. Correct. So it is understood it is positive because we are following the positive complex rule. So hexaamine platinum 4. Then your counter ion, you do not have to write di, tri, tetra, nothing. Counter ion you have to write as it is. So hexaamine platinum 4. Then give the space chloride. Are you getting it, everyone? So it is understood since there is positive 4 charge, we have a chlorine which are 4 negative. Getting it? So that's why we do not write bi, tri, tetra, no need. So hexaamine, platinum 4, chloride. Come on, write it down and done in the chat box. I'll share the list of all the possible ligands. I'll share the list of all the possible ligands. Done. Jason, is it done? Okay, so ligands. Okay, now look at the names. Okay, while in the IUPAC we have 3 types of ligand. Again, anionic, which are your negative ligand. We have neutral ligands. Okay, we have a neutral ligands, and we have a cationic ligands. We have a cationic ligands. Okay, so only for anionic, we end name with O. We end name with O. For example, look over here. I am sharing all the possible anionic ligands list. Okay, I am sharing all the possible anionic ligands list. After the class, please write it down. Okay, so look over here. All the possible anionic list. Okay, so if you have chloride ion, okay, we are going to do the example. What we will write? We write in the IUPAC nomenclature, we write chlorido. Okay, if I have bromide, bromido. Cyanide, cyano. Oxide, oxo. So if you notice each and everything, Jason, it is ending with what? It is ending with O. It is ending with O. This I'll tell you. But for now, remember, all of the anionic ligand, if your ligand contains a negative charge, we will end it with O. Is it clear? Come on, give me yes or no. Jason and Anthony, Sasidaran, is it clear? Is it clear? Okay, we have to end it with O. Okay, so that was your anionic ligand. Okay, anionic ligand we ended with O. Then we have a neutral and positive ligand also. That also I'll share with you. Okay, see, look over here. These are your neutral ligands. These are your neutral ligands. Just a minute. Okay, these are your neutral ligands. 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 Okay. Then we have also 2 or 3 positive ligands that also I'll share. Okay. For positive ligand, we write IUM. We write IUM in the end. Okay. We have only 4 positive ligands. So for the positive ligand, neutral ligand we write as it is. Only difference is for water we write aquo. Okay. Aquo or aqua, both will work. Okay. Remaining thing we write as it is. We write as it is. Okay. So only thing you have to remember, everyone, negative we will end it with O. Negative we will end it with O. Okay. Negative we will end it with O. Okay. Positive we will end it with IUM. Okay. Neutral we'll write it as it is. Water we write it as aquo. Water we write it as aquo. Okay. Is it clear, everyone? Come on, give me yes or no in the chat box. Is it clear? Can we do another example? Can we do another example? Shall I give another example, Jason? Can you solve it? Yeah? Can we try?
Sir,
Chalo, let us try. Let us try. Suppose, Jason, and suppose I have
sir,
complex leg. Let us take the example this.
sir,
Yes, Arjuna?
sir, can you just repeat the points, sir, for positive and negative, because I left the session, sir, in
Acha.
between.
Okay. So, Arjuna, look over here. So, we have all 3 types of ligand: anionic, cationic, and neutral. Okay, anionic, neutral, and cationic. I have shared all the possible ligands that you have in the coordination chemistry. Okay, so anionic ligand we end it with O. So if I have chloride, Sarjana, we will end it with chlorido. Bromide, bromido. Cyanide, cyano. Carbonate, carbonato. Oxalate, oxalato. Sulfate, sulfato. Okay, so we end it with O. Neutral ligand we write it as it is. Neutral ligand we write it as it is. Only thing is for water we write aquo. For water we write aquo. And positive ligand we end it with IUM. That is only thing we have discussed. Okay. After the class you have to write the list of all the ligands in your book. Okay. Now do this example, everyone. Suppose I have Jason, look over here. Suppose I have CO, NH3 4, H2O, Cl, Cl. Come on, try this. What is our order? First, we write down the ligands alphabetically. Then we mention the central metal atom. Then we write down the oxidation state. Then we write down the counter ion without any di, tri, tetra. Come on, I have given you hints enough. Try it. Try it. Try. It is fine if you go wrong. I am there to help, but at least try. Come on, try. It is fine even if you go wrong.
Sir,
Yes. Who's
tetra,
this? Jason.
tetra, I mean, aqua, chlorido, 3 cobalt.
Okay, let us wait. Okay, I got your answer. Let us wait. Let everyone solve it. I will not say it is correct or wrong. Let everyone solve it. Then I'll correct or wrong. I'll say. Come on, write down the answer. Ganesh,
Yes, sir.
kindly check with Sashidharan. He is not answering. He has turned his camera off. I think he is not in front of his PC. Now automatically the camera has turned on. Oh my God, Sashidharan. Hmm? I was calling you from so long, Sashidharan. You have not.
No, sir. Like I was sitting here only, sir, but
Uh,
I
but
was
no
not.
answers.
No, sir. I got like sprain in my leg, so I
So I
can't.
could not type because I got sprain in my leg.
No, sir. I was like laying,
Okay.
so was not turning on the camera.
You could have informed me.
Sir, I can keep like Bluetooth keyboard, so I can keep in my
Please,
labs and.
but at least inform me so that I know. Okay. Chalo. Anyways, Ganesh, it's okay. Do not call his parents. Anyone else who want me to talk to your parents? Jason, should I? No. Okay. Chalo. Anyways. Okay. Okay. It is fine. Sasidaran, it is fine. But at least inform me, no? It is not like it is little bit disrespectful. Okay, so you can inform me, you can keep your camera off if there is an issue, but at least tell me that there is an issue. Okay, so anyways, okay, so we have some answers. We have answers from N calling it as aquo chlorido tetraamine cobalt 2 chloride. Okay, then we have answer from Jason calling it as tetraamine aquo chlorido 3 cobalt chlorine. Okay, then we have answer from Sarjana that is not yet come. I know that is not yet come. Sarjana, come on, try. Sasidaran, come on, try. Okay, look over here, look over here. What is the answer? First we have ligands. Okay, Jason and you have both of you have done little mistake. Let me point it out. Okay, let me point it out. What mistake you have done? Okay, so over here, ligands. Okay, first I'll start with N. N ligands. What are our 4 ligands over here? Yes, Sarjana, what are our 4 ligands? We have one NH3 that is 4 NH3 that is a amine or amine. Okay, we have H2O that is aquo. Okay, that is aquo. Okay, or aqua. Then we have Cl that is Cl. We write it as what? We write it as chloride, but it is negative ion, so we write it as chlorido. Correct. We write it as chlorido. And even though there is di, tri, tetra, penta, hexa, hepta, whatever it is, you have to go in this order. Are you getting it? And you do not have to write down since there is a tetra, that does not mean you will consider T. No, you will consider the alphabet of a ligand. Are you getting your mistake? And yeah, you will consider the alphabet of ligand, not the alphabet of di, tri, tetra, penta, hexa. No, we will consider the alphabet of ligand. So according alphabetically, what will come first? Your amine will come first, then aquo, then chlorido. First amine, then aquo, then chlorido. So over here, tetraamine, we have tetraamine. Anthony, what we have? Tetraamine. Then we have aquo. Okay, then we have chlorido. Okay, then the oxidation state. Anne has given 2. Jason has given 3. Which is the correct one? Sarjana, come on, tell me. What is the correct oxidation state over here? We have 2, we have 3. Anthony, did you try? Jason, if I dissociate, what charge will come on top? Water is also neutral. Water, you are considering water as aqua, no? Amine neutral, Jason, isn't it? So for neutral ligand, the charge is 0, not the 1. For the neutral ligand, the charge is 0. So what I'll do, x plus 0 plus 0 minus 1, and the top over here we will have plus 1. Correct? So minus 1 goes that side, become plus 1 plus 1, it becomes 2. Is it clear, Jason, Sarjana, Anthony? Is it clear? So we have tetraamine aquochlorido 2, and now here comes the mistake of Jason. Jason, oh, one more. Even I have done the mistake. Okay, I did not write metal, no? Okay, after chlorido, I'll write the metal, that is cobalt. Okay, I'll write the metal, that is cobalt. Okay, cobalt, yeah, cobalt 2. Then here comes a mistake, Jason. Mistake number 3, Jason. We do not write what is our counter ion. It is Cl. Okay, no matter what it is, we write down the name of the ligand. Are you getting it, Jason? We do not write chlorine. What do we write? We write chloride. We write the chloride. Yes, Jason, are you getting it?
Okay.
Yeah. If I dissociate, Jason, see, simple logic. If I dissociate, what I'll get? I'll get the Cl minus. No, our chlorine is Cl2. Cl minus is not a chlorine. Chlorine is Cl2. Cl minus is chloride. Okay. So tetraamine aquochlorido cobalt 2 chloride. I hope it is clear. It looks very long, but it is easy. It is easy, isn't it? Yes, Sarska and Jason, Sasidaran, I hope you are getting it. Yeah. Shall I give you one more? Okay. Suppose I have, okay, try this now. Try this. Cr, let us say H2O4, Cl2I. Cl2I. Come on, try this. Jason, Anthony, Sarjana. Now, Sarjana, I expect an answer from you. Okay, come on. Come on, try. Jason, Anthony, come on, try. Come on, try. Come on, try. Okay, we have one answer from Anne. See, and in the IUPAC nomenclature, it is very bad. IUPAC nomenclature is very evil in the marks. Okay, there is no half marks in this. Okay, either there is 1 or there is 0. Either there is 1 or there is 0. Come on, Sarjana, come on, try. Jason. Bapre. Sasidaran, what is the spelling? Apo, chromium. Okay. Sasidaran, you have written the correct, but look at the spelling a little bit and write it again. Anne has done a mistake. She has realized after Sasidaran has put his answer. Bye. Sarjana, where do we have clicked? I know my handwriting is not that good. Okay, but this is not 2, this is 4, no? Sasidharan, it is not Apua. Like in south, what do we call water? Wait, I know this. I know this. Wait. Neer, no, I forgot. What water is called Jal? What do you call? In, like I know it is Tamil is Neer. Neer, yes. I know. Neer. Yeah. Okay.
Sir,
So,
in like
Sasidharan, even if you, yes,
in Tamil literature and all, like that ancient Tamil and all, we call water as Neer.
Neer. I know this name because see, I'm also a GSB. If you have heard about it by any chance, okay, it's a caste, so we also call like it as a Neer. Okay, anyways, but Sasidharan, even if you would have written tetra Neer, then I can understand that you mean water. What is Apua? Have you ever heard something called as Apua?
Sir,
APUA.
it's Q, sir, instead of
Ah,
P.
getting it? Imagine you calling that DC hero as Apua man. Yeah, it sounds so bad. Yeah, it is not Apua man. It is Aqua man. Yeah,
Yes,
isn't it? Imagine you calling Jason Momoa, the Aquaman, as Apua man. Apua means little bit short in Hindi. Okay, anyways. Okay, so it is Aqua. Okay, so we have tetra, okay, or we can call it as aquo, both will work. Tetra, aquo, then we have chlorido, so tetra, aquo. Jason has done a mistake again. Jason, how many chlorido we have? Yes, Sarjana, what is bi over chlor? I feel like I am dumb who cannot talk while reading your answers. Sarjana, if I read your answer, it is by IO chlor. I do not know how to read it. Have you only sent it to me or you have sent it in all chats? You have only sent it to me? So I should paste it in all chats so that everyone should read it. No, I cannot copy this, but I will this one. Okay. So, like, tell me honestly, like, if I read it, won't I sound like the person I cannot talk? How will I read it, Sarjana? Yeah. By Ayuva Chlorida. What should I read? Yeah. I can talk. Yeah. You are making me sound like I am the person who cannot talk. I talk by sign language. No, no. Yeah. So it is not by IO. Okay. It is tetra aquo because we have 4 aquo. Correct? We have 4 aquo. Then, Jason, how many chlorido we have? You have written tetra aquo chlorido chromium 3. But how many chlorido we have? You have not mentioned that. Yeah? You have not mentioned that. So we have 2 chlorido. So dichlorido, tetra aquo, dichlorido. Then we will write down the metal completely, that is chromium. Yes, without any space, metal, chromium. Then we write down the oxidation state. All of you have got it correct. That is, we write it in the Roman, that is 3. Okay. Then in the end, counter ion, that is iodide. Is it clear, everyone? Come on, give me yes or no. Is it clear? Is it clear, everyone? Is it clear? Chargena, is it clear? So tetra acts as dichlorochromium 3 iodide.
Sir, no sir,
Yes.
it's not clear for me, sir.
Acha. Where did you get
Sir,
stuck?
in the previous question, we took as tetra. But why can, sir, I thought it would be hexa, sir, because NS3, 4, H2O, Cl.
Okay, okay. So see, look over here, Sajna. We are naming individual ligand. Okay. So for example, we have three ligand over here. What are those three ligand? We have amine, we have aquo, we have chlorido. You can keep yourself on mute for a minute. Okay. So we have three ligands, Sajna, correct? That is amine, aquo, and chlorido. Correct. So we do not write hexa for all the ligand. If I write hexa, then that means I have 6 amines, but I do not have. Okay, so I have to write about individual, correct? So amine, how many amine I have? I have 4 amine. 4 means tetra, correct? So I have written about amine, done. Tetra amine. Then I'll write about water, that is aquo. I have only one aquo. So I do not write mono. If I do not write anything, that means what, Sajna? That means it is understood, it is 1. Okay, so aquo. Same is with the chlorido. Okay, 1, so I do not write anything. Okay, okay, Jason. So over here, I'll write chlorido, then cobalt 2 chloride. Are you getting it, Sajna? I got it. Why did you get confused? Wow, nice, nice, nice way to get confused. Impressive, because I have only written tetra, so you thought everything should be hexa. Okay, but I am talking about individual ligand. Are you getting it, Sajna? Sajna?
Yes, sir.
Sir, is it pronounced Sarjana or Sarjana?
Sarjana.
Sarjana. Okay, I'll pronounce it correctly. Similarly, okay, over here, Sarjana, I am talking about 2 ligands. What are those? One is aquo, another is chlorido. Correct? So how many aquo, how many water ligands we have, Sarjana? I have
4
4.
aqua and 2 chloro,
So
sir.
how will I write? Tetra aquo, aquo, finish. Done. Then I'll move to chlorido. How many chlorido I have? 2 chlorido. So dichlorido, chlorido, done. Then I have written about metal, then I have written about oxidation state, then I have written about counter ion. Clear?
Okay, yes, sir.
Okay, chalo, let us go ahead. Yeah, is it clear? And yeah, do not do the silly mistake. Okay, do not do the silly mistake. Okay, one more interesting example I am giving, which is little bit different. Okay, which is little bit different. Okay, suppose I have ligand like, first of all, what is this ligand? First, let us talk about this ligand itself. PC6H5 3. Okay, what is this ligand? Anyone? I'll only tell you now. Wait, this is called as triphenylphosphine. What do we call it? We call it as triphenylphosphine. This is your triphenylphosphine, a neutral ligand. Triphenylphosphine, a neutral ligand. Okay, triphenylphosphine, neutral ligand. So let us say I have 3 triphenylphosphine, okay, attached to a metal which has Cl. Come on, try this name now. Sarjana, come on, Sasidaran, try. Sasidaran, your mistake. You do not have to give space everywhere. You have to write everything together till oxidation state. Only counter ion you have to write it down separately. Are you getting, Sasidaran? Yeah? You have to write down the central atom separately. Counter ion separately. Remaining everything come together. Okay? So this is triphenylphosphine with a neutral ligand, which is a neutral ligand. Okay? Come on, try. I hope RH, everyone knows what is RH? RH is rhodium. Chalo, I have helped that also. RH is rhodium. Come on, try, Sarjana. RH is rhodium. RH is rhodium. RH is rhodium. One try. Come on, try. And just give me a minute. Just give me a minute. Yes, come on. What did you get? You knew the rule and what did you search with? Yes, Sasidaran.
My chemistry
Search
teachers
Jana.
in school said this while teaching organic chemistry somewhere.
Okay, fine.
Not sure where, but in one of those lessons it was given as a
It
rule.
is there. That's why I took this example. Okay. Yes, Sasidaran, come on, try. Sarjana, what did you get? Fine, even if it is wrong, you are excused today if it is wrong. Come on, tell me. Okay. Very good, Sasidaran. So over here, the name Sarjana, did you get it? Come on, try. Oh, why? What happened? I have given you the name of ligand. First, write down the name of ligand that I have already written. Triphenylphosphine. Now, Sasidaran, look over here. And triphenylphosphine. I already have triphenylphosphine. Sarjana, sorry. How many triphenylphosphine I have? I have 3 triphenylphosphine. So, Sasidaran, you tell me, will it look good if I write try? Yeah. Is it try till you succeed? That is our formula. Yeah. But that will not look good in our coordination compound. What? Triphenylphosphine. What are we telling him? That you try something, it does not look good, no? Yeah. So that's why whenever your ligand contains number, okay, whenever your ligand contains number, for example, try, even in ethylene diamine, okay, even in ethylene diamine, there is a word di. See, that number, even if it is at the start, even if it is in the between, doesn't matter. It is a number. So for that, we use the nomenclature as tris. We use the nomenclature tris. Okay, we use the nomenclature tris. So this is tris triphenylphosphine. Okay, so 2 is bis, 3 is tris, 4 is tetrakis. 4 is tetrakis. Okay, so even if the number is in between, for example, ethylene diamine, that di is in between, but I'll use, if I have more than 1, 2 ethylene diamine, I will use bis, tris, tetrakis. Are you getting it, everyone? Yes or yes? Sarjana, are you getting it? Sasidaran, is it clear? And is it clear? Yes. So I will write, do not write any bracket. Okay. Do not write any bracket. Where did you go, Kevin? Do not write any bracket. Just write down tris, bis, tetrakis.
Login ID expired again, sir.
Okay. So whatever, oh, it's okay, Kevin. So whatever you have, bis, tris, tetrakis. Okay. So write down that.
No, sir, like just for differentiating the 2 tri, I gave a bracket for triphenylphosphine.
I got the logic, but we do not have to write down the bracket because we are using the term tris now. Okay, so it is automatically, you have separated it. Getting it?
Sir, in case of that diamine thing, if there are 4 diamine means, we will like write tetrakis diamine.
It's not diamine, tetrakis, ethylene diamine. Are you getting
Tetrakis ethylene
ethylene
diamine.
diamine? Getting it?
Yes, sir.
Okay. So if you have di, tri, tetra, anything in your name, you will use this nomenclature bis, tris, tetrakis.
So for this
Okay.
also, we should not leave any space and write.
You do not have to leave any space. You have to write down everything till oxidation state altogether. Okay. So tris, triphenyl phosphine, our metal is rhodium. Then the oxidation state that you have got it, this is neutral. So this is +1 goes to that side. Yeah, is equal to +1. So it is 1. Okay. Then we have chloride. Is it clear, everyone? Come on, give me yes or no. Is it clear? Is it clear? Okay. Now, negative complex, we'll do it in the next lecture. Okay, now I'll assign you the class assessment. Just hold on, just give me a minute. Okay, I'll assign you the class assessment. Just a minute. Do not leave the session, especially Sasidaran. In the class assessment, do not leave. Just a minute. So this is, as I told you, this is a very, very easy chapter. Very easy chapter, something different from what you have done till now. Correct? So it's better to score marks in this. And definitely one question on nomenclature. Why did I took this much of time to teach you nomenclature? Because one question on the nomenclature definitely coming in your exam.